Hello everyone, you are welcome to today's class. Our topic today is scalars and vectors, but our concentration is actually on vector addition. We are already familiar with the concept of scalars and vectors, but let's refresh our memory again. In physics, all physical quantities can be classified as either scalars or vectors. Scalar quantities are those quantities that have only magnitude but no direction. Examples are distance, speed, mass, energy, density, power, length, area and volume, time, and so on and so forth. While vector quantities are those quantities that have both magnitude and direction. Examples are displacement, velocity, weight, acceleration, force, impulse, and so on and so forth. Vectors are represented by straight lines with an arrowhead indicating the direction of the vector. The length of the line is drawn proportional to the magnitude of the vector. Scalar quantities of the same kind are added by simple arithmetic rule. For example, a car travels a distance of 20 kilometers and later continue the journey, traveling for another 2 kilometers. Altogether, it has traveled a distance of 32 kilometers. Vector quantities cannot be added with such arithmetic except when they are in the same direction. Vector addition. In the addition of vectors, I'm going to classify them as 1. Parallel vectors, 2. Inclined vectors, 3. Resolving more than 2 vectors. So we are starting with parallel vectors. If two vectors, let's take P and Q to be the two vectors acting in the same direction. From the diagram there, we can see P and Q acting in the same direction. P, we use 10 Newton for P and 15 Newton for Q. The resultant vector will now be equal to P plus Q. You can see an arrowhead on top of the letter used to represent a vector. That is to tell you that it is a vector. So the resultant vector, which is P plus Q, our final answer for the resultant vector will now be R is equal to 10 plus 15, which will be equal to 25 Newton. If these two vectors are now acting in opposite direction, P is acting opposite to Q from the diagram there, we should remember that P is still 10 Newton and Q is still 15 Newton. Our resultant vector will now be equal to Q minus P. Because Q is bigger than P, Q will come first. So our resultant vector will now be equal to 15 minus 10, which will now be equal to 5 Newton. Now let's look at this scenario. John and Paul are to pull a body as shown in the diagram. Both are pulling in the same direction. This is a combined effort. So the two forces acting on the body will be added to get the resultant force acting on the body. If both John and Paul pulls in opposite direction, as shown in the diagram, let's assume John pulls with a force of 10 Newton and Paul pulls with a force of 15 Newton. The resultant force will be 15 minus 10, which will be equal to 5 Newton. Now we want to look at inclined vectors. When two vectors are inclined at an angle to each other, they could be added either by using the parallelogram method or the triangle method, depending on the nature of the question. Let's start with the parallelogram method. The parallelogram law of vectors states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, the diagonal of the parallelogram drawn from the point of intersection of the vector represent the resultant vector in magnitude and direction. The formula is given by r squared is equal to p squared plus q squared plus 2pq cos theta, where r is the resultant vector, p and q are the two vectors inclined at an angle, and theta is the angle between the two vectors. So now we are going to take example 1. Find the resultant of two forces of 10 Newton and 20 Newton, acting at 60 degrees to each other. Using the formula R square is equal to P square plus Q square plus 2PQ cos theta, we will now substitute the values of 10 and 20, and we now have R square is equal to 10 square plus 20 square plus 2 times 10 times 20 cos 60 degrees. When we simplify it, we have R square is equal to 100 plus 400 plus 400 times 0.5. You see that one in the bracket, we have to finish it up before we add up. If not, the arithmetic will be wrong. So when we finish that up, we have 200. And 100 plus 400 will give you 500. So 500 plus 200 will be equal to 700. The square root of 700 will be 26.46 Newton approximately. So R is equal to 26.46 Newton. Example 2. Find the resultant of two forces of 60 Newton and 40 Newton acting at 120 degrees to each other. We apply our formula R square is equal to P square plus Q square plus 2PQ cos theta. By the time we substitute into our values, R square will now give us 60 square plus 40 square plus 2 times 60 times 40 times cos 120. 60 square will give us 3,600, 40 square will give us 1,600, and 2 times 60 times 40 will give us 4,800. Cos 120 will give us minus 0.5. So by the time we add 3,600 and 1,600, we will get 5,200. By the time we multiply 4,800 by minus 0.5, we are going to have minus 2,400. If we take away 2,400 from 5,200, we are going to get 2,800. The square root of 2,800 will give us 52.9 Newton. Using the parallelogram method, the addition of these vectors can also be done by scale drawing method. We are taking question 1 we have done before by calculation. We need to choose a suitable scale, but it is advisable to choose a large scale to minimize errors. So we will take 1 centimeter represents 2 Newton. In that case, 20 Newton will be equal to 10 centimeter and 10 Newton will be equal to 5 centimeter. So we are going to draw our diagram now using the scale drawing method. We'll draw a straight line. When you draw this straight line, I prefer to use a straight line, then cut out my 10 centimeter. So if we use a scale rule, measure 10 centimeter from the scale rule and cut out the 10 centimeter with my compass. Then I'll take my protractor. You can see the mark where the cross is on the protractor. It has to be on the line. And where the point is from your 10 centimeter, then you measure out with your protractor 60 degrees. And draw a straight line from the bottom to the top. Long line. Then you get your compass. Measure out 5 centimeter for the other vector. Then we cut out 5 centimeter with our compass. The other way, we take 5 centimeter and swing a large arc. I prefer to take my 10 centimeter from my diagram instead of the scale rule. And you swing the arc. Then you join from where they intersect to the 10 centimeter at the other end. Then where they intersect, you join it to the other side of the parallelogram. You must be very meticulous about this. Then we draw from the diagonal. We draw the diagonal from the point of intersection to where the arc cut each other. This is our resultant force. And we'll measure the resultant force. When we measure the resultant force, we are going to get 13.3 centimeter from our rule. Converting 13.3 centimeter, converting it back to Newton, we will multiply our 13.3 by 2 according to our scale. When we multiply 13.3 by 2, we will have 26.6 Newton, which is very close to our answer by calculation. Taking question 2, we are going to use a scale of 1 centimeter represents 10 Newton. In that case, our 60 Newton will be equal to 6 centimeter and our 40 Newton will be equal to 4 centimeter. So for question 2, we'll draw a straight line. After drawing the straight line, we are going to measure out with our compass 6 centimeter. Then we cut out our 6 centimeter from the straight line at the middle. Then we'll get our protractor and measure out 120 degrees. And we use our scale rule to draw a straight long line. Then we get our compass again and measure out 4 centimeter. Then with the 4 centimeter, we'll swing an arc on this side. We go the other way, we swing an arc also 4 centimeter. Then we join, we take another 6 centimeter, we swing the arc, and then we draw a straight line from where the arc intersects each other and join them together again at the bottom. And then we are going to draw our diagonal from the point of intersection to where the two arcs meet. That is our resultant force. If you measure this length, you are going to get 5.3 or something close to it. Then by our scale, we will multiply by 10. When we multiply by 10, we are going to get. I hope you enjoyed the lesson. If you have any question, do well to drop them at the comment section and I will respond to them as soon as possible. Don't forget to subscribe so that in the next lesson, you will be the first to know.